All right, so we start chapter 9 today. Chapter 9 starts with conics. Well, the whole thing is conics, but most of it anyways. It starts with conics. These are things that you should have seen in Algebra 2. These are circles, parabolas. We get into ellipses and hyperbolas in the first 3 sections. So the good news is that a lot of this is review. Okay, so we start with circles and parabolas, and then like I said, 9.2 is ellipses, and 9.3 is hyperbolas, and then we'll pause for a quiz before your spring break, which is begins next Thursday. So we'll quiz next Tuesday on those 3 conics, and then we get into rotations and stuff towards the end, which is super fun. All right, so conics are, a conic section is the intersection of a plane and a double napped cone. So if you look at the double napped cone, which kind of looks like an hourglass on the right hand side, depending how you slide a plane or like a rectangular shaped object, how you slide that through forms these different kinds of conics. So the first, if I just slide a plane through horizontally, I get that round, perfect round circle. If I slide it at an angle, I get that oval shape, which is an ellipse. If I chop off the edges on the top or the bottom, I get that U, which is your parabola. And if I slide something through vertically, I get 2 parabolas that point away from each other, which are called hyperbolas. So those are the 4 conics that we'll focus on in the first half of this chapter. Today we're going to do we're going to do circles and parabolas. So a circle is the collection of all points x, y that are equidistant from a fixed point. We did talk about circles all the way at the beginning of the year, but the standard equation is x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. Are you missing the equation on that one, right? Mm-hmm. Yeah, okay. So if, like every other chapter, if you're starting to build a reference sheet, the standard form of a circle is definitely something I would add on there, although hopefully you know it by now. But you can get it added on there. So the first equation says the point 1, 4 is on a circle whose center is at -2, -3 is shown in the figure. Write the standard form of the equation of the circle. So I'm going to just rewrite this standard form, x minus h squared plus y minus k squared equals r squared. When I rewrite this as an answer, I keep x as x, y as y, but I plug in the point, hk, and I plug in the r. So what information do I already have? Just from what they give me. I have which one goes in the actual equation at the end? The center or a point on the circle?
Center.
The center. Good. My hk I already have, right? Which is -2, -3. So x minus a -2 becomes x plus 2. Y minus a -3 becomes y plus 3. So I already have that part just from what they give me at the beginning. What I don't have yet is the radius. There's more than one way to do this. What's one way? Yep, I could plug in all of those coordinate points. So this would be my x, and this would be my y, and this would be my h, and this would be my k. 1 minus a -2 becomes plus 2 squared plus y, which is 4, minus a -3 becomes plus 3 squared equals r squared. 3 squared plus 7 squared equals r squared. 9 plus 49. R squared is 58. If it had asked for the radius, then I would square root both sides and simplify it if I need to, but this doesn't even ask for the radius, it just wants the equation, which means I can simply come back up here and I can leave that 58 as my, here, 58 as my r squared, and there's my answer. So again, if it had said, find the radius and then get the equation, then I would want to square root that 58. But because it's just asking for the equation, I can leave it the way it is as squared. What's another way to do that if you didn't plug in?
Distance formula?
Good, I can find the distance formula from my radius to my center, and then just don't forget to square it. So in my opinion, it's easier to do what we did because people make mistakes by forgetting to square. Okay, so just keep that in mind. Questions on that one? All right, example 2, putting an equation into standard form. This time it says sketch the circle given by the equation and identify its center and its radius. So this equation, x squared minus 6x plus y squared minus 2y plus 6, is not in standard form. How do I get it in standard form?
If you take out 2x times x minus 6, then you take out the x and y.
Yeah, but our goal is to get it to be something squared, right? I need it to be x plus or minus a number squared plus y plus or minus a number squared equals, and then the radius squared, right? So I have to actually, I'm going to group these together. I'm going to group these together. I'm going to bump the 6 to the other side. And now I have to make those perfect square trinomials. Do we remember how to do this?
As soon as you start, we'll get it.
Mm-hmm. You remember a little thing called complete the square? Yes, we are going to complete the square, but we're going to complete it twice. Once for the x and once for the y. So I'm going to complete the square on this first parentheses by taking my second term, which is 6, dividing it by 2, I get 3, and then squaring it, and I get 9. I'm going to add it here, and I'm going to add it here. Balance the equation out. So add it to the left side, add it to the right side. Then I'm going to do the same thing for the y. I'm going to take this 2, divide it by 2, I get 1, square it, I get 1, add it here, and add it to the other side. Now my goal was to make these perfect squares so I can factor them into a binomial squared. So I square root the first term, I square root the third term, take the sign from the middle, put it in parentheses and square it. Plus, square root the first term, square root the last term, take the sign from the middle, put it in parentheses and square it. And then negative 6 plus 9 is 3, plus 1 is 4. And now my equation's in standard form. Do we remember complete the square? COVID hasn't completely squashed your brains. It's a good sign. So what this is asking for is sketch it and find the radius and the center. So you got to find the radius and center before you sketch it. What's the radius of this equation?
4.
Square root it, right? Square root of 4, which would be 2. What's the center of this equation? 3, 1. Always flip your signs. So if I'm going to graph it, I'm going to go 1, 2, 3, up 1, and then I'm going to go up 2, right 2, down 2, left 2, and make my circle. So there's a lot of complete the squares with these conics. Okay, with circles we get to do it twice because there's 2 variables that are squared. With hyperbolas we get to do it twice. With ellipses we get to do it twice. You definitely need to know your complete the squares. Questions on that one? All right, example 3 says find the x and y intercepts. This also goes way back. How do we find the x intercepts? Good. Plug 0 in for y. How do we find the y-intercepts? Good. Plug 0 in for x. So I'm going to start by plugging 0 in for y. X minus 4 squared plus 0 minus 2 squared equals 16. X minus 4 squared plus negative 2 squared equals 16. X minus 4 squared plus 4 equals 16. Subtract the 4. X minus 4 squared equals 12. And then I square root both sides, making sure I put a what in front of that square root? Plus and minus. Good. So I get x minus 4 equals plus and minus the square root of 12. And then add the 4. Twelve is 3 and 4, so that can get simplified to 2 root 3 plus 4. So these we will leave exact. There are 2 of them. One is 2 root 3 minus 4, comma 0. And one is 2 root 3 plus 4. Sorry, no, sorry. Wait, let me reverse that order. One is 4 minus 2 root 3, 0. And one is 4 plus 2 root 3, 0. So those are the first ones. Those are my x-intercepts. Then come my y-intercepts. So for these, I'm plugging 0 in for x. 0 minus 4 squared plus y minus 2 squared equals 16. Subtract that 16. Square root both sides. There's no such thing as plus or minus 0, so it's just 0. And y is 2. So when x is 0, y is 2. This is again my x-intercepts and my y-intercepts. Because it's a circle, there could be 2 of each. There could be none of each. There could be 2 of one and like 1 of the other, like it is right now. Like this is touching the y-axis and crossing through the x-axis twice. So it could happen, just depends on where you're moving your circle. Okay, so then comes parabolas, right? So again, we're going to do 2 conics today. The first was circles and the second is a parabola. So a parabola is a set of all points x, y in a plane that are equidistant from a fixed line, which is called a directrix, and a fixed point, the focus, that are not on the line. The midpoint between the focus and the directrix is the vertex, and the line passing through the focus and the vertex is the axis of the parabola. So a couple of different things, and when we covered parabolas this year, it was in a functions section. So the parabolas were always an x squared, right? And so we put it in standard form. We always did like the negative b over 2a, or we found the vertex by doing hk. These are in different format because these are not just functions, which means these parabolas can be up, down, right, or left. You did cover this in Algebra 2. I know because I teach it, okay? But you did cover this in Algebra 2, but it's a different format than what we did at the beginning of the year. So you've seen parabolas a lot, okay? But this time we're talking about a parabola that has obviously a vertex. They all have a vertex. But when we talked about them with functions, we didn't talk about the focus or the directrix. So it's been a little while for you to see these terms, okay? Remember, the focus is inside the scoop. So no matter where your parabola is facing, the focus is always inside it, and the parabola wraps around it. And the directrix is always the opposite direction. The parabola cannot cross through the directrix. The directrix is a line, so it's an x equals or a y equals depending on if it's vertical or horizontal, okay? And the focus is always a point, so this is going to be an xy coordinate point. The distance from the vertex to the focus and the vertex to the directrix are the same. So if I'm counting the distance from the directrix to the focus or the directrix to the vertex, it's the same. If I'm doing directrix to focus and I want to find the vertex, it's the midpoint between them. So standard equations for parabolas, there are 2 sets. The first is if you have a vertex that's not at 0, 0. So if my vertex is not at the origin, there are 2 formulas. X minus h squared equals 4p y minus k. And y minus k squared equals 4px minus h. Notice the h is always with the x, the k is always with the y. If it is an x squared parabola, then this is pointing up or down. If it's a y squared parabola, it's pointing left or right. If it's positive, it's up and right. If it's negative, it's down or left. So if the 4p is positive and it's an x squared, I point it up. If the 4p is negative and it's an x squared, I point it down. If it's a 4p positive and it's y squared, I point it right. 4p negative, I point it left. If the vertex lies at 0, 0, then we simply don't have an h and a k because they would be 0. So this is x squared equals 4py or y squared equals 4px. Again, a positive x squared means I point it up. Negative x squared means I point it down. Positive y squared goes to the right. Negative y squared goes to the left. And the positive or negative will actually be on the 4p, not on the x itself. So that's a little bit different from the first time that we did it. So again, if you're keeping a reference sheet, add the parabolas on, okay? All right, so the left-hand side is your up and down, your vertical parabolas. Again, this would be a positive an x squared and a 4p. It points up. The distance between the vertex and the focus is p. The distance between the vertex and the directrix is also p. In this case, this would be a negative 4p. This would be positive, okay? And then if it's horizontal, the y is squared. If it's a positive 4p, then it points right. If it's a negative 4p, it points left. So some people like to create like a chart and plug points in. I think for me, I'm a visual person, so I'm going to show you how to do it that way. But know that you could always just take your p and add it or subtract it on from your vertex, which I'll talk about too. For me, the pictures help. All right, so this one says, find the standard form of the equation of the parabola with a vertex at the origin and a focus at 0, 4. So I'm going to start by drawing out just like rough picture of what this parabola would look like. First of all, if the vertex is at the origin, it's there. If my focus is 0, 4, I don't go left or right at all. I go up 4. What direction is this parabola facing? Up. Which tells you what already? What variable is squared? The x. Positive 4p or negative 4p? Positive 4p because it points up. So that I already know. My vertex I already know would be 0, 0. Which means I'm using my standard x squared equals 4py equation. So as soon as you know vertex is at 0, 0, I know I don't need an h and a k. And then I know my direction from where the focus is. Now the only other piece of information I need is p. How do I find it? Oh, you can. You can. Yeah, there is. But so Maria just said you can plug in x and y, and absolutely can. Yeah. How else could you do it? What does p represent? Mm-mm.
The distance of the focus to the center.
So how could I find that?
Just counting.
Just count it. Yeah, right? Distance from the vertex to the focus. So 1, 2, 3, 4. That's p. P is 4. So now I get x squared equals 4 times y. X squared would equal 16y. All right, B says vertex at the origin and focus at 1, 0. Oops. So vertex at the origin, again, means it's at 0, 0. Which means I use my shorter equations. Focus at 1, 0. Which way is this one facing? To the right. What variable is squared? Y. 4p positive or negative? Positive, because it's right. If it was left, it'd be negative. And what is p? 1. Y squared equals 4 times 1 times x. Y squared equals 4x. Everybody still good? All right, find the standard form of the equation of the parabola with a vertex at 1, 3 and a focus at 1, 5. So as soon as you read this, hopefully you catch, this is no longer a 0, 0 scenario. This has an HK. So then I plot that information. 1, 3 is my vertex. 1, 5 is my focus. Which direction is this going? Up. Which means it's a x squared and a positive 4p. So I know it's x minus h squared plus, or not plus, sorry, equals 4py minus k. So I have my h, which is 1, x minus 1 squared equals 4 times p. I don't know what p is. How do I find it? It's 2. And how do you know that? Because you counted. Good job. Okay. You could also plug in that point, but it takes a lot more work, right? So if you're one of those people that doesn't like the visual and you like to plug in things, by all means have at it. But okay, so the last part of this is the y minus k, right? So y minus our k, which is 3. And then I just get x minus 1 squared equals 8, y minus 3. And there's my equation in standard form. Questions on that one? All right, this one says find this vertex, the focus, and the directrix of the of the parabola. So this is not in standard form, right? We got to get it into standard form. How do we do that?
Great question.
You can complete this square. Yeah. What would you do before you completed the square to make your life a little easier? What do we normally do when we have fractions? Get rid of it. How do you get rid of it? Multiply everything by what? Okay, so let's start with 2. So 2y equals negative x squared minus 2x plus 1. If I want to complete that square, if I want to factor that, can the x squared be negative? No. So what can I do to get rid of that? Just multiply or divide by everything by negative 1. So negative 2y equals x squared plus 2x minus 1. Now is the right side a perfect square already? Oh, so close.
I'm not going to talk.
No, don't you dare stop. What's wrong with the last number in order for that to be a perfect square?
It's 3 a y alone.
It doesn't. I can factor it. I'm just going to start saying yes to you even if it's wrong and right, and then I'll just correct it later. All right. Can you square root negative 1? No. That last term has to be positive in order for it to be a perfect square, right? If it was positive, this is already a perfect square. All I'd have to do is factor that right side. Okay, but it's not. So I'm going to move the 1 to the other side. Negative 2y plus 1 equals x squared plus 2x. Now I'm going to complete this square. So divide 2 by 2. I get 1. Square it, I get 1. So I want to add a 1 here and here. And I get negative 2y plus 2 equals x squared plus 2x plus 1. Factor that right side. And I get x plus 1 squared. Now I got the squared part good. I can even switch this because we're so used to being this squared on the left-hand side. I can switch this sides. Now the problem's on the right-hand side. You can't have anything attached to your x or your y, which means I have to factor out the negative 2. And now it's in standard form. So which direction is this parabola facing?
Up.
So close. You got the up or down right, but what's my 4p? What's the
Oh, it's
sign on it?
negative.
It's negative, so it's down. So my vertex is negative 1, 1. It's going to point down. Negative 2 equals my 4p. So p is negative 1/2. Now p is just a distance, so we actually don't need the sign there. We just need to know I'm going up 1/2 to get the directrix, and I'm going down 1/2 to get the focus. So my vertex is this. Up and down is where I moved to get those 2 points, which means my focus, the x, is going to stay the same. And then from this 1, I'm going to subtract a 1/2 because I'm moving down. And then to the y, I'm going to add the 1/2 to get the directrix. This is a line. So my directrix is a y equals, because it's a horizontal line, 1.5. So p is what we move, not 4p. Yeah. Oh, it says, it looks like up. I got you. Yeah,
We've been saying up and
that's
down.
okay.
Right,
All right, the bell's probably going to ring in this example, so I'm just going to tell you what we're going to do, and then I'll finish on the video. This says find the vertex, the focus, and directrix of the parabola. Okay, is this in standard form? No. What do I do to get it into standard form?
Complete.
I'm going to have to complete the square. Now the first thing, the good news is I only have to complete the square once because it's a parabola, right? So I actually have to bump the 4x to the other side. Y squared minus 8y equals negative 4x minus 12. And then I'm going to complete the square on the y. So 8 divided by 2 is 4. 4 squared is 16. That's what I'm going to add here and here. So I complete the square on the left. Y minus 4 squared equals negative 4x plus 4. And then remember, you can't have anything on the x. So we take out the negative 4 and we get x minus 1. What direction does this parabola face? Down. It's a y squared with a negative 4 as my 4p. So my vertex is 1, 4. It's going to point down. So negative 4 equals 4p. P equals negative 1. But remember, we just worry about the distance. I'm going down 1 to get the focus, which means 1, 3. I'm going up 1 to get the directrix, which means y equals 5. All right, homework is on, web is signed, but I want to stress so very much that the questions that have multiple choice graphs, you need to have work for. You need to graph these by hand. Your test and quiz will not be multiple choice on the graphing part. So you need to make sure you're learning how to graph them by hand.